In this final lesson on solving quadratic equations by a variety of techniques, we're going to start out and talk about something called the discriminant. And it actually comes from the word discriminate, which is to differentiate based on characteristics. Sometimes it has a negative connotation, but really the word discriminant, it is a math term. A discriminant is a number that can be calculated from A, B, and C in a general quadratic equation, and it tells us how many and what kind of solutions a quadratic equation has. So the formula for the discriminant is b squared minus 4ac. I hope that this looks familiar. This is the expression that is the radicand of the quadratic formula. So the kind of number you get as the radicand tells you lots about the kind of answers. If the discriminant is greater than 0, and that is a way of saying if it's positive, you get two unequal real solutions. Okay, they are real. They might be irrational, but they are real. If the discriminant is equal to 0, then you get one, although it would be repeated, real solution. Finally, if the discriminant is less than 0, you get two non-real imaginary solutions. You could call them non-real complex solutions. But if the discriminant is less than 0, there will be i's in your two answers. So let's take a look at this. Problem number 1. Make this a little bit bigger. It says, compute the discriminant, then determine the number and type of solutions of the given equation. The instructions do not say solve it. So we will not solve the equation, we will just predict the kinds of solutions it will have. The discriminant is b squared minus 4ac. In this quadratic, set equal to 0 like it needs to be, in other words its general form, a is 1, b is -3, and c is -5. So the discriminant is parentheses -3 squared minus 4 times 1 times 5. You can use your calculator to evaluate that expression, or you can do it. -3 squared is 9 minus, that's like a -4 times 1 times 5 is -20. So the discriminant here, whoops, I made a mistake. This 5, and I'm wondering if you're catching it, this 5 should have been -5. So that means it's plus 20, and that greatly affects this answer. Now it's -4 times 1 times -5, so the discriminant is 29. So your first answer is 29. Keeping these statements in mind, you may want to write these down. This is a number. 29 is greater than 0. So you're going to get two unequal real solutions. Okay, let's look at the next one. Compute the discriminant. If I'm going to do that, this needs to be in general form, which it is, and the a value is 6, the b value is -7, and the c value is 6. The discriminant, d is equal to b squared minus 4 times a times c. So it is in parentheses -7 squared minus 4 times the value of a is 6 times the value of c, which is 6. This is going to give me 49 minus times positive gives me minus, and that product is 144. So this discriminant is -9. 95. This is a number less than 0, so if I go back to my list, if it's less than 0, you get 2 non-real imaginary solutions. I'm sorry. Hope I didn't just make you dizzy. I think I made myself dizzy. All right, slowly. Here we go. Since this is a negative, it is less than 0. I'll type it in here. And then there are 2 imaginary solutions. Let's look at number 3. I'm given general form again. A is 1, B is negative 16, C is 64. D is equal to B squared minus 4AC. So it is, in parentheses, negative 16 squared minus 4 times 1 times 64. That gives me 256 minus 256, which is 0. When a discriminant is 0, you only get one, and it is real, solution. It is a repeated solution because you've probably recognized, we've talked about, that quadratics have 2 answers. But what this tells you is that this quadratic was a perfect square trinomial. And so yes, it gets 2 answers, but they're the same. So we don't usually write it down twice, so there is one unique real solution. Number 4. Again, it's given in general form, so I can simply say A is 1, B is negative 7, C is negative 7. The discriminant is B squared minus 4AC. So it is, parentheses, negative 7 squared minus 4 times 1 times negative 7. That's 49. Negative times positive times negative. That means plus 28. So I get 71. So my discriminant is 71. That's a number greater than 0. That means that I have 2 unequal real solutions. Number 5. Starting with number 5, we're going to continue to solve quadratic equations, but it says the method of your choice. So I'm just going to pick a method for each one. I'm going to tell you why I'm picking it, and if you choose another method, hopefully it will be valid and give you the same answers. All right, this first one, I'm going to try it. Let's see. I believe I will set it equal to 0 because with that 5 there, it's not going to be friendly for completing the square, and it's definitely not ready for the square root property. So if I move the 4 over, I get 5x squared minus 19x minus 4 is equal to 0. I would say that the best choices right now are either factoring or the quadratic formula. And I believe this is going to work by factoring. So I'm going to try it that way. You certainly could have used the quadratic formula. Whoops. I don't know why that jumped. All right, plus 1 minus 1. I'll have 5x and 1x. And I think I'll put the 4 down here and the 1 here, because remember, for the 5 we had 1 and 5. For the 4 we either had 1 and 4 or 2 and 2. I chose 1 and 4. My outer product is negative 20. My inner product is 1. That means my middle term is correct. So factoring has worked nicely for me. The 0 factor property says 5x plus 1 equals 0, or x minus 4 equals 0. Over here, subtract 1, so 5x is equal to negative 1. X is equal to, do your division, and I get negative 1 over 5. Over here, I get x is 4. So my solutions in any order, -1/5 and +4. You could have pretty easily done that also by the quadratic formula. I chose factoring. Number 6. I believe I'm going to at least set it equal to 0 and see what I'm going to do from there. I will have 3x squared. This 19x will come over as minus 19x plus 6 equals 0. Looking at that, I can tell that I can do my factoring. I could have chosen instead to try the quadratic formula, but I saw the factors when I looked at this. The last sign's positive, so that means plus plus or minus minus, and in this case minus minus. I know that I need a 3x and an x. I'm trying to get a 19, so I could try 2 and 3 to get 6, or 1 and 6. I'm going to choose 1 and 6. I want to make sure the 6 is an outer pairing up with the 3, and the 1 is here. That gives me an outer product of -18x and an inner product of -1x, and those factors work. If you're a little bit tentative about using factoring, then you could have used the quadratic formula. So here we go. So 3x minus 1 equals 0, or x minus 6 equals 0. That means 3x is 1. Divide by 3, x is 1/3, or x is 6. Any quadratic that is factorable could pretty easily be done by the quadratic formula. Number 7, when I look at this one, I see something squared and a constant. I immediately think square root property when I don't see a plain old x. So I'm going to say 6x squared equals 324. I need to isolate the x squared, so I'm going to divide by 6. X is equal to, that's going to be 54. I'm so sorry. X squared is equal to 54. Now I take the square root of both sides. My goodness. I've got to be careful not to touch certain icons. So the square root property says x is equal to plus or minus the square roots of 54. Can I simplify that? Well, I hope that everybody realizes that the square root of 54 is the square root of 9 times the square root of 6, or 3 times the square root of 6. X is equal to plus or minus 3 times the square root of 6. It could be separated into 3 square roots of 6, comma, -3 square roots of 6. You could not have factored this because the answers are not rational. You could have set it equal to 0, use the quadratic formula. It's just that b would have been 0. All right, number 8. Although it's not the most popular technique, I'm going to, just so I do it again, I'm going to use completing the square. I can look at this and know that even if it's equal to 0, I cannot get the factors of 4 to have a difference of 2. This is not factorable. I could use the quadratic formula, but I just want to practice this technique honestly. So I have x squared plus 2x, I'm going to put plus a blank, equals 4 plus a blank. Using my red colored pen, maybe, there we go. I'm going to take 2, take half of it, which is 1, square that, still get 1, add 1 to both sides. The left-hand side is a perfect square trinomial, and it's x, grab this, plus 1 equals 5. Now, although I'm using completing the square within it, I'm using the square root property. So this is going to be x plus 1 is equal to plus or minus the square roots of 5. Subtract the 1, and I get x is equal to negative 1 plus or minus the square root of 5. I can leave it as a combined answer if I have access to this symbol. If you have to separate it, it's negative 1 plus the square root of 5, comma, negative 1 minus the square root of 5. Now, I didn't mind using the completing the square process. I did notice it was already in the format and that this term was even, so I wasn't going to invite any fractions into the problem. That's why I chose completing the square. You could have written it as x squared plus 2x minus 4 equals 0, identified a, b, and c, and used the quadratic formula. Don't worry, I will use the quadratic formula on a problem before I quit. When I look at number 9, I immediately see square root property because I see a quantity squared equal a constant. So I have open parentheses 3x minus 5 squared, closed and then squared, equals 25. Square root property, I get 3x minus 5 is equal to plus or minus the square root of 25. And yes, that simplifies. So I have 3x minus 5 is equal to plus or minus rational 5. But I'm not finished. I need to solve for x. So add 5 to both sides, but put it in front. So 3x is equal to 5 plus or minus 5. Divide by 3. X is equal to 5 plus or minus 5 over 3. And I need to get my two rational answers. I have 5 plus 5 over 3. And I have 5 minus 5 over 3. The top one gives me 10 over 3, and I can't simplify that. The bottom one gives me 0 over 3, which I need to write as 0. My two solutions are the fraction 10/3. Whoops, for some reason I'm getting my email. And please stop. And 0. 10/3 and 0, it doesn't matter about the order. Let's look at number 10. Y squared minus 8y plus 17. It's in general form. It is not factorable because the factors of 17 cannot add up to be 8. So I choose the quadratic formula. You could have used completing the square, but I wanted to try something different. I have a is 1, b is negative 8, and c is 17. This time it's y equals instead of x. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Y is equal to negative b means the opposite of b, so that's 8 plus or minus the square root of negative 8 squared minus 4 times the value of a, which is 1, times the value of c, which is 17. All of that over 2 times 1. Use your calculator to do any calculation you want. I have 8 plus or minus the square root of negative 8 squared is 64. This can be minus 68 over 2. So I have y is equal to 8 plus or minus the square root of negative 4 over 2. Can you simplify that radical? The square root of negative 4, I hope that you see immediately that that is 2i. So y is equal to 8 plus or minus 2i over 2. You see that this rational, this one, and this one all contain a common factor of 2. So I can reduce. 2 goes into 8 4 times. 2 goes into 2 once. 2 goes into 2 once. And I get 4 plus or minus 1i over 1. Some of those ones I don't write. It is 4 plus or minus I, and we don't write denominators of 1, we don't write coefficients of 1. So your answers separated could be 4 plus I, comma, 4 minus I. Once again, I hope you observe those happen to be conjugates. Let's look at number 11. What method do you want to use? Well, even though it's not in the right format, I believe I'm going to set it equal to 0, and it's not going to be factorable. I think I'll use the quadratic formula again. So I have x squared minus 4x plus 7 equals 0. I subtracted 4x, it came over here as negative. I added 7, it came over here as positive. A is 1, B is negative 4, C is 7. So using the quadratic formula, and you were welcome to use completing the square if you wanted to. That method would work also. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b means the opposite of b, so it'll be 4 plus or minus the square root of parentheses negative 4 squared minus 4 times 1 times 7 all over 2 times 1. So x is equal to 4 plus or minus the square root of negative 4 squared is 16. Negative 4 times 1 times 7 is negative 28 all over 2. I might need some more room. Well, that, we'll see. I don't think that gave me any more room. So I have x is equal to 4 plus or minus the square root of, this will give me negative 12 over 2. And by the way, if I had wanted to take a minute to determine the discriminant based on A, B, and C, I would have gotten this negative 12. I'm just pointing that out. I doubt that anybody, just out of curiosity, had done that. So I need to take the square root of negative 12. This will be the square root of negative 4 times the square root of 3. The square root of negative 4 is 2i square root of 3. So back to the problem, I have equal sign 4 plus or minus 2i square root of 3 all over 2. Again, sorry, things are hopping around. Trying to just get my highlighter. I see that 2 is a common factor of the numerator and the denominator. 2 goes into 4 two times, 2 goes into 2 once, 2 goes into 2 once. X is equal to 2 plus or minus, I don't write coefficients of 1, so it's I times the square root of 3. I don't write denominators of 1, so this is all I get. Separating it, it is 2 plus I square root of 3, comma, 2 minus I square root of 3. Those are my two solutions. All right, let's keep going. I think we only have one more problem to do, and I get to pick any method I want. Well, looking at this, it's equal to 0. I immediately see a common factor. That means I'm going to use factoring. Just because I've chosen a method in this video does not mean it's the method you want to choose. It's just what occurred to me. So I have 3x squared minus 7x equals 0. I see a common factor of x times 3x minus 7 equals 0. So x is 0, or 3x minus 7 is 0. Adding 7 means 3x is 7. Divide by 3, x is 7/3. My solutions are 0 and 7/3. All right, so you have all these tools, and we will focus more on using the grapher to solve quadratics and other kinds of equations in a future video.